Hey everyone, welcome back to Rev Games Academy. In today's video, we'll learn how to create a simple player movement script in Unity. This is perfect for beginners or anyone looking to get a quick start on controlling a character. Let's jump right in. I've set up a basic scene, and this capsule will serve as our player. You can use any 3D model for your player, but make sure to add a rigid body component to it so it can interact with physics in the scene. Now, let's write the script to handle player movement. Right-click in the project window, create a new CSharp script, and name it Player Movement. Once the script is created, attach it to your player object to start implementing the movement functionality. Let's break down how this player movement script works. First, we start by declaring a public variable called speed, which controls how fast the player moves. The movement logic happens in the update method. Here, we capture the player's input using input.getAxis method for both horizontal and vertical axes, which correspond to the WASD keys, or arrow keys. This input is used to create a vector3 variable called movement, which represents the direction the player wants to move in, with the y-axis set to 0 since we're working on a flat plane. Finally, we use the transform's translate method to move the player. This method takes the current position of the transform, adds the calculated movement scaled by the speed and time.delta time, and applies it in world space. This makes the movement smooth and frame rate independent, ensuring consistency across different devices. Now let's test it out. Press play and use the WASD keys, or arrow keys, to move the player. You can see that the player moves smoothly in the direction corresponding to the key you press, providing a responsive and intuitive control experience. As you just saw, the player fell down. This happens because the rotation is influenced by physics. To prevent this and avoid unwanted rotations, we need to adjust the rigid body's constraints. By restricting rotation on all axes, we ensure the player stays upright and stable, even when interacting with other objects or forces in the game. This is particularly useful if you don't want physics-based rotation affecting your player's movement. This is one of the basic player movement scripts. However, when working with physics objects, it's crucial to use Unity's dedicated methods instead of transform.translate. Using this method bypasses Unity's physics system entirely, which can lead to unpredictable behavior, especially when interacting with other physics objects. Let me show you an example to understand this. Let's enable the physics objects in the hierarchy and play the scene. When we use transform.translate to move the capsule and collide with the nearby wall, a glitching effect occurs. This happens because the capsule has a rigid body attached, so Unity's physics engine tries to resolve the collision by pushing the object back. At the same time, we are pressing the movement key to move towards it, which causes the capsule to move forward and backward rapidly, creating a glitching effect. And this is exactly why we should limit the use of the translate method when your game involves physics. Instead, use rigid body-based methods like rigidbodies.movePosition or applying forces, as these ensure that the movement is handled by Unity's physics engine, resulting in more accurate and smooth behavior. Let's now switch to using rigidbody.movePosition and check the result. To add the rigidbodies method, first we need to define a variable for the rigidbody component. Since the script is attached to the capsule, we can assign the variable to the rigid body of the capsule using getComponent rigid body. We added this in start function as reference of any variable should be assigned before using it. After that, we can use the rigidbody.movePosition method instead of translate. It's important to place this in the fixed update method because physics calculations should be updated at a fixed rate, making the movement more consistent and avoiding overheat. As we are using fixed update to call the method, we will also use fixed delta time. Previously, when using the translate method, the position was updated relative to the current transform, so you only needed to provide the movement vector. However, with move position, you must specify the target position explicitly to start from the object's current position. Now, let's test the result. As you can see, when the capsule collides with the wall, it stops as expected, without any glitching issues. This is because the movement is now handled by Unity's physics system through rigid body's move position, ensuring proper collision detection and resolution. You might wonder how this works in 2D. It's very simple. The same movement method applies, but since we're in a 2D environment, we use a vector 2 for the position instead of a vector 3. Here, the z-axis is irrelevant, and the y-axis is used for moving up and down, and also, instead, we will be using rigid body 2D. Let's switch to our 2D scene and test it out. Keep in mind that in 2D, we need to zero the gravity to avoid the object from falling and constrain the rotation. As you can see, the capsule moves perfectly in response to the input, just as expected. There are many ways to implement player movement, but this is one of the most basic approaches to get started. Since we're starting with the fundamentals, don't worry if there's a concept you find unclear. As we progress through future tutorials, everything will start to make sense. If you need any clarification in the meantime, feel free to let me know in the comments. If you found this video helpful, don't forget to give it a thumbs up and subscribe to the channel for more tutorials like this. Thank you for watching, and I'll see you all in the next video.